Hi guys! Welcome sa Engineered Math Channel. Sa video na to ay tuturo ko sa inyo ang inductors. So kung gusto nyo itong matutunan, just keep on watching. Okay, so tulad ng resistors at capacitors, ang inductors ay isa ring passive element. Basically, ang inductor ay mako-consider natin na counterpart ng capacitors. Marami tayong iba't ibang uri ng inductors base sa iba't ibang applications din nito. Okay, so ngayon, i-define natin kung ano ba ang inductors. Inductors, a passive element used to store energy in its magnetic field. It consists of a coil of conducting wire. So sabi ko nga, isa siyang passive element but this time, nag-store siya ng energy in its magnetic field. So, ini-store niya yung energy through its magnetic field in the form of current and then, after some time, i-release niya ito para magamit ng ibang element sa isang circuit. Okay? Now, it consists of a coil of conducting wire. So, kung i-consider natin yung construction ng isang inductor, isa siyang wire na wind sa isang coil. So, ito yung itsura niya. So, ito yung core natin na merong different types of materials. So, pwedeng iron, steel, plastic, at air. So, kung air, ibig sabihin wala tayong core. Sa hangin lang natin wind yung inductor. And then, dahil nga wind natin, magkakaroon tayo ng number of turns. Okay? And then, meron din tayong cross-sectional area doon sa circle o doon sa core na nabuo natin. So, ito yon. And then, meron din tayong length noong kabuang winding na nabuo. Okay? So, ito yung length L. So, mamaya, ituturo ko sa inyo yung formula para mahanap natin yung inductance ng capacitor using these parameters. Okay? So, ito yung symbols ng inductor. So, parang meron tayong wire na naka-wound. So, parang merong curly wire na ganito and then yung dalawang terminal niya. Ito yung air core inductor na fixed. Ibig sabihin, wala tayong specific core. And then, meron naman tayong iron core inductor na fixed din. So, same lang din sa symbol ng air core inductor. Ngayon, meron lang tayong parallel line sa taas niya na nagde-denote na meron na siyang iron core. And then, meron din tayong variable inductor. So, kung ano yung symbol ng air core inductor na fixed, talagyan nyo lang ng slant line na may arrow. Okay? So, ito yung mga illustration o litrato ng iba't ibang inductors na pwede nating makita sa electronics. Ito yung solenoidal wound inductor. So, ito yung part A. Tapos, yung toroidal inductor. So, gumagamit tayo ng toroid as a core. And then, meron tayong chip inductor. So, ito yung mga pwede nating makitang itsura ng inductor sa iba't ibang electronic components like PCB or circuit board. Okay? So, the term coil and choke are also used for inductors. Okay, so, tandaan nyo na pwede ring tawaging coil at choke ang inductors. Okay? Now, punta na tayo dun sa formula for inductance. So, sabi ko nga, meron tayong formula in terms of the parameters na kinonsider natin kanina. So, the inductance L measured in Henry or H is equal to N squared mu A over L, where N is the number of turns, mu is the permeability of the core, A is the cross-sectional area, and L is the length. So, base dito sa mga value na meron tayo doon sa construction noong inductor, may solve natin yung inductance nung inductor. Okay? So, using this formula, pwede nating makonclude na kapag marami tayong turns dito sa construction natin ng inductor, ay mas mataas din yung magiging inductance natin. At kung mas malaki yung cross-sectional area ng core natin, mataas din yung inductance natin. Kung maliit naman yung length noong inductor coil natin, syempre mataas din yung inductance kasi inversely proportional yung length. Okay? So, ito lang yung dapat nating tandaan kapag hahanapin natin yung inductance, itong formula na to. Okay? Next, now if we consider a current that is allowed to pass through an inductor, it is found that the voltage across the inductor is directly proportional to the time rate of change of current. So, dito na papasok yung voltage to current relationship of the inductor. So, halimbawa, meron tayong pinadaang kuryente dito sa inductor natin na IL, and then magkakaroon tayo ng induced voltage VL such that it is directly proportional dun sa derivative or time rate of change of current with respect to time. And then, yung magiging constant of proportionality ay yung inductance natin na L. So, ito yung dapat nating tandaang formula for the voltage-current relationship of inductor. Okay? Now, we can define inductance as the property whereby the inductance opposition to the change of current flowing through it, measured in henries or H. So, therefore, we can define inductance as the property of inductor that opposes the change in current. So, kung sa capacitor, it opposes the change in voltage at yung resistance, it opposes the current itself. Sa inductor naman, it opposes the change in current, yung inductance. Okay? Tapos, measured ito in Henry in honor of Joseph Henry. So, using this formula, madederive natin na yung 1 Henry o yung L natin ay equal sa 1 volt second over ampere or volt second per amp. Okay? Tapos, pwede na natin i-graph yung voltage to di-dt relationship of the inductor, wherein yung y-axis natin ay yung voltage dun sa inductor and then yung x-axis natin ay yung di over dt o yung di-dt. And then, ang slope natin ay yung L. Okay? Now, other formula na pwede natin gamitin for inductor ay itong mga formula na ito. So, for the current IL, base dun sa formula natin na VL equals L di dt, pwede natin ma-derive dito yung current naman sa IL. So, manipulate lang natin tong equation na to. Mako-compute natin yung IL as 1 over L integral of T0 to T VDT plus IT0. So, itong IT0 siya yung initial current doon sa inductor. Okay? And then, for the power, which is measured in watts, it is the same as the formula sa voltage times current. So, VL times IL, or substituting the value of VL na LDI dt, ito yung magiging formula niya, LDI over dt times IL. Okay? And then for the energy measured in joules or J, it is equal to 1/2 Li squared. Okay? So ito yung mga dapat nating tandaan na formula for inductors. Okay? Kasi mamaya, gagamitin natin ito kapag magsasolve tayo ng example problems. Now, pumunta na tayo sa characteristics of inductors. So, number 1, we have an inductor acts like a short circuit to DC. The voltage across an inductor is 0 when the current is constant. Okay, so kung sa capacitor, ang equivalent natin for capacitor in DC is an open circuit or high impedance or resistance. Kapag inductor naman, it is a short circuit to DC or therefore, zero resistance. So, for example, meron kang supply current and then meron kang inductor. At DC operations, let's say, na-supplyan na ng current na to, let's say, current I, itong inductor L natin for a certain period of time, magiging short circuit na siya. So, parang ang equivalent circuit niya ay ganito. Okay? So, therefore, dahil short circuit na siya, yung resistance niya ay 0 or yung voltage niya is equal to 0 na. At the first instant na sinupply pa lang itong current, hindi pa siya short circuit sa DC. But as time goes by, during this DC condition, then ang tendency ay mag-short na siya ng tuluyan. And therefore, yung voltage induced dun sa inductor ay magiging 0. Just like sa formula na VL is equal to L di dt. So, since nga sa DC na yung current natin ay hindi nagbabago, itong di over dt natin ay magiging 0. Kasi yung delta natin for I is 0. So, therefore, VL is equal to 0. So, yun yung naging dahilan kung bakit yung voltage sa cross ng inductor is 0 when the current is constant. Base din dun sa formula ng inductor. Okay? For the next characteristic, we have the current through an inductor cannot change instantaneously. However, the voltage across an inductor can change abruptly. So, since nga na ang characteristic ng inductor ay nagre-resist ng sudden change in current. Therefore, dapat meron itong waveform na continuous for the current. May illustrate natin to by using the formula for the voltage induced in an inductor, which is VL is equal to L di over dt. So kung magpo-focus tayo sa di over dt, let's say na na-violate natin itong characteristic number 2 ng inductor kung saan nag-change instantaneously yung current. Therefore, itong delta I natin, let's say kahit anong value, 1 amp, and then itong delta T natin ay approximately 0 dahil nga nag-change instantaneously. Therefore, yung delta T mo ay approximately 0. So, let's say microsecond range. Therefore, magkakaroon ka ng mataas na value for dIdt or approximately infinity. Which is, ito yung dahilan kung bakit magkakaroon tayo ng high voltage spike sa inductor. Ito yung mga kadalasang nangyayari kapag meron tayong switching circuits na mayroong inductor, like the SMPS. So, kaya itong example natin dito na waveform, hindi niya violate yung characteristic number 2 kasi, for example, at origin, ito yung initial value ng current. And then, at this portion, or this T1, let's say ito yung T0, hindi niya na-reach itong level na to instantly, kundi nagkaroon siya ng delta T na may value na hindi 0. Hindi kasi dinaanan niya ba tong slope na to bago niya na-reach itong level na to. So therefore, possible itong waveform na to. Unlike dito sa second waveform na impossible, kasi nag-start sa 0 itong current nung inductor, and then instantaneously na-reach niya tong level na to, which is yung duration ng delta T na to is 0, right? Therefore, magkakaroon ka ng infinite spike or high voltage spike dito sa portion na to. The same as dito sa portion na to, let's say nasa level siya na to, and then suddenly napunta siya dito. So therefore, yung delta T mo dito ay 0. So therefore, na-violate nga rin yung second characteristic nung inductor. So therefore, impossible itong waveform na to for inductor. Although possible kasi magkakaroon ka ng high voltage spikes. Okay? But however, the voltage across an inductor can change abruptly. So, itong waveform na to, pwede itong mangyari or pwedeng maging ganito yung waveform for voltage across an inductor. Okay? Next, we have, like the ideal capacitor, the ideal inductor does not dissipate energy. The energy stored in it can be retrieved at a later time. The inductor takes power from the circuit when storing energy and delivers power to the circuit when returning previously stored energy. Okay, so tulad ng ideal capacitor na nag-store ng energy through voltage, itong ideal inductor din, nag-store din siya ng energy this time through current. At hindi ito nagdi-dissipate ng power unless nga hindi siya ideal kasi meron na siyang mga parasitic resistance and capacitance. So, tulad ng capacitor, ini-store din muna noong inductor yung energy through current, and then at a later time, pinapasa niya lang ito sa ibang components within a circuit. So, parang wala kang nade-dissipate na energy or power sa kanya. Okay? Next, we have a practical non-ideal inductor has a significant resistive component called winding resistance Rw and winding capacitance Cw due to the capacitive coupling between the conducting coils. So tulad ng sinabi ko, there's no such thing as ideal inductor. So laging meron tayong non-ideal inductor. Kasi hindi tayo pwedeng mawalan ng mga parasitics. Like for example, dito sa inductor, meron siyang winding resistance. So ito yung nagdudulot sa inductor para magkaroon ng loss. Kasi yung wire natin, 'di ba, meron siyang resistance kahit maliit. And since nga yung inductor natin ay made up of wire na winind natin, therefore meron din tong resistance. Same as meron din tayong nabubuong winding capacitance na ito. So ito yung non-ideal form na pwede nating maging itsura kapag kino-consider natin yung practical inductor. Okay? Now, let's solve some examples para ma-illustrate natin yung iba't ibang formula at concepts na natutunan natin for inductor. Okay? For example number 1, we have the current through a 0.1 Henry inductor is I of t is equal to 10t e raised to negative 5t amps. Find the voltage across the inductor and the energy stored in it. Okay, so magsimula tayo dun sa voltage induced. Diba yung formula natin ay VL is equal to L di dt. Okay, so substitute lang natin yung value. Yung L natin ay 0.1. And then, i-derivative natin yung given current as a function of time natin, t e raised to negative 5t. So, ano ba yung derivative nun? So, constant yung 10. So, as is lang siya. And then, ito lang yung i-derivative natin. So, product formula. So, applying product formula for derivative. So, copy muna natin yung first function na t. And then, differentiate natin yung e raised to negative 5t. Ano yun? Negative 5 e raised to negative 5t. And then, plus, this time, ikakopy naman natin yung second function na e raised to negative 5t. And then, multiply natin sa derivative ng first function na t, which is just 1. So, therefore, simplifying further, we have 0.1 times 10 is simply 1, right? Or kahit hindi na natin isulat. And then, simplify lang natin to, magiging negative 5t e raised to negative 5t plus e raised to negative 5t. Okay? Then, pwede natin i-factor out itong e raised to negative 5t. So, we have e raised to negative 5t, then negative 5t plus 1, then volts. Or pwede natin pagbaliktarin, we have e raised to negative 5t, 1 minus 5t volts. Okay? So, therefore, this is the voltage induced. Now, for the energy stored, we can use the formula energy is equal to 1/2 Li squared. So, substituting the values, we have 1/2, L is 0.1, and then I squared. So, yung I natin, squared natin tong function of I natin. So, 10t e raised to negative 5t quantity squared. So, we have 1/2 of 0.1 times itong 2 distribute natin. So, magiging 100, then t squared, then e raised to negative 10t. Simplifying further, we have, simplify natin itong constant, equal yan saan? 5, right? So, 5t squared e raised to negative 10t. The unit is joule. So, therefore, the final answer is 5t squared e raised to negative 10t joules. Okay? Next, we have find the current through a 5 Henry inductor if the voltage across it is V of t is equal to 30t squared, t is greater than 0, and 0, t is less than 0. Also, find the energy stored at t is equal to 5 seconds. Assume I of v is greater than 0. Okay, so apply natin yung formula for the current. So, I is equal to 1 over L integral of V of t dt from t0 to t plus I of t naught. Okay? So, substitute natin yung values. L is 5 Henry. So, 1 over 5 integral of, so, t natin initially ay 0 and then yung t natin is undefined. So, walang sinet, right? So, as is lang na t, and then copy natin kung ano man yung binigay na voltage. So, ito yung kokopyahin natin kasi dito tayo sa positive time. So, we have 30t squared multiplied by dt plus I of t naught natin is 0. Right? So, simplifying further, we have 1/5 of 30t squared dt. Integral nun ay 30 t cube over 3 kasi plus 1 tayo, diba? So, we have 2t cube. Then, evaluate from 0 to t. So, therefore, we have 2t cube minus 2 0 cube or simply 2t cube amps. So, therefore, this is the current. Now, We also want to find the energy stored at t equals 5 seconds. So, using the formula na E is equal to 1/2 Li squared, so substitute natin yung value. 1/2 L is 5, then yung nakuha nating I as a function of t is 2t cubed, and then square pa natin. So, we have 1/2 5, then 4, distribute natin yung exponent, then t to the 6. Simplifying further, we have 1/2 times 5 times 4 is 10t to the 6. And then substitute natin yung time natin for t na 5. Kasi yun yung hinahanap, di ba? 5 seconds. So we have 10 times 5 to the 6. So approximately 156.25 kilojoules. So therefore, this is the energy stored at t equals 5 seconds. Okay? Next, we have consider the circuit in figure below. Under DC conditions, find A, I, VC, and IL, and B, the energy stored in the capacitor and inductor. So notice, meron tayong under DC conditions na statements. So therefore, apply natin yung equivalent representations ng inductor at capacitor under DC conditions. So for capacitor, open siya under DC, while yung inductor naman, short siya under DC. So kung i-redraw natin itong circuit, magiging ganito siya. So plus minus 12 volts, yung resistor copy lang, so 1 ohm. Yung resistor copy lang 4 ohm. Yung resistor copy lang 5 ohms. And then itong capacitor na to magiging open kasi under DC siya. Okay, so plus minus PC. And then itong inductor magiging short siya kasi under DC. Okay? So kung i-analyze natin ngayon yung circuit, itong resistor na to parang naka-float. So therefore, parang ang equivalent circuit na lang natin ay itong 12 volt na merong dalawang resistor in series na nakakonect. So, pwede na nating makuha yung I na hinahanap natin dito. Paano? Using Ohm's law na lang. Kung mapapansin nyo, itong I magiging equal siya dito sa IL. Kasi isa lang yung dadaluyan nila, di ba? Kasi wala naman na to. So, using Ohm's law, magiging I is equal to V over R, right? So, ano yung V? 12 volts divided by yung sum ng resistors na to. So, 1 plus 5 ohms. So, magiging equal siya sa 2 amps. Okay? Now, ano naman yung voltage dito sa capacitor? So, since itong 4 ohm resistor na to ay parang naka-float na lang, pwede nating mahanap yung VC at this node to this node. Right? So, therefore, parang ito yung voltage dito sa 5 ohm resistor. So, ano yon? Using ohms law ulit, VC is equal to IR naman. So, IR. Yung I natin, yung nakuha nating 2 amp, kasi isa lang naman dadali sa kanya, diba? So, 2 amps times yung 5 ohm resistor. Magiging 10 volts. Okay, so therefore, meron na tayong I, IL, tsaka VC. So, hanapin naman natin yung energy stored in capacitor inductor. So, for the capacitor, we have energy for the capacitor is 1/2 CV squared. So, substitute natin yung values. 1/2 C is 1 farad, right? Squared. And then, yung nakuha nating VC is 10 volt squared. So, using calculator, masasolve natin yung energy doon sa capacitor as 50 joules. And then, lastly, for the inductor, we have 1/2 Li squared. So, 1/2 L, yung L ng inductor ay 2 Henry. And then, yung current na nakuha natin ay 2 amps. So, 2 amps quantity squared. So, solving for EL, we have 4 joules. Okay? So, that's it. So, ganun lang mag-analyze ng circuit involving inductors. So, yun yung lahat ng mga characteristics at formula na pwede natin gamitin kapag nagko-consider tayo ng circuits with inductors. So that's it for this video. So sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.